y equals x squared plus 8x plus 12. Let's start by finding our vertex. And our vertex is going to be negative b over 2a. We've got 8 there, so negative b be negative 8. And then over 2 times 1, which is just 2. So we're going to start with our x value of negative 4. We're going to plug that in. Negative 4 squared plus 8 times negative 4 plus 12. Negative 4 squared is 16. 8 times negative 4 is minus 32 plus 12. 8 times negative 4. Yeah, there we go. 16 minus 32 be negative 16 plus 12 would be, what is that? Negative 4? So the vertex of negative 4, negative 4. Wish I could say I did that intentionally. That worked out nicely. All right, let's go to the next step, which would be the x-intercepts. And we've got x squared plus 8x plus 12. Can we factor that? 12, 8. What numbers can we do that for? How about 6 and 2? Hey. Oh, and our a value is positive. So when the parabola is going to go up, and it's equal to 1. So I can skip ahead to my shortcut. X plus 6 times x plus 2. X squared plus 2x plus 6x plus 12. That should work out just fine. So x equals negative 6, negative 2. That's just my set of two numbers. So my x-intercepts are going to be negative 6, negative 2. And those are lining up nicely. They're symmetrical. They're 2 away from my vertex point. Let's go to y-intercept. We're going to plug in x for 0. And that is going to be really far away on our graph. I wonder if we're even going to find that. Let's see. 0 squared plus 0 plus 12. 8 times 0, I guess, technically. 0 squared is 0 plus 8 times 0 is 0. Y equals 12. So that is 0, comma 12. And that is going to be off of our graph way up there somewhere. Okay, good to know. So we might need to plot 2 other points. I don't know if we even needed to do that. If that's the graph that you provided, maybe take a look at it and say, Jeff, I think I'm just going to do negative 5 and negative 3. I think that's going to be my easiest course of action. Remember, when you're plugging in, you're replacing that variable. You put everything inside the parentheses. It's going to clean up some of that stuff. Negative 5 squared plus 8 times a negative 5. Plus 12. Negative 5 squared would be 25 minus 40 plus 12. 25 minus 40 is what? Negative 15 plus 12 would be negative 3. Do we feel good about that? I sure do. All right, we've plotted 4 points, one of which is off the graph, a 5th one up there. We think that negative 3 is also going to be negative 3. Let's just do a quick check. Negative 3 squared is 9. 8 times negative 3 is negative 24 plus 12. 9 minus 24 plus 12. 9 plus 12 is 21 minus 24 is negative 3. I think we found another point. I think we did it. So use your best instincts there as well. The y-intercept not as helpful on this graph. Way up there. There we go, we've graphed another parabola. Alright, the third example, as always, comes with a catch, so let's take a look at that carefully. 3x squared minus 12x plus 15. And looking at our graph over there, this is going to be definitely a positive parabola. And yeah, let's see what our vertex is first. Negative b over 2a, negative 12 would be 12 over 2 times 3 is 6. 12 divided by 6 equals 2. So if our x is 2, we're going to plug that back in. 2 squared minus 12 times 2 plus 15. Ooh, that is written poorly. 2 squared is 4. 4 times 3 is 12. 12 minus 24 plus 15. 12 minus 24 is negative 12 plus 15, 3. So my vertex here is 2, 3. Let's go over here on the graph, 2, 3. I think it should be right about there. All right. Now, before we go on to our x-intercepts, we know that the parabola is going to be positive. Here is the x-axis here. It is not going to go down. We know it's not going to go down. It's not negative. It is a positive parabola. So our x-intercepts, there's not going to be any roots. Roots. None. If there were going to be roots, if you were doing just a quadratic equation, this would be no solution. So let's skip that. We don't want to do that. It's not going to be worth our time. Actually, it's not going to yield anything. So let's go to the y-intercept. I think that we can clearly see it's going to hit there. Y-intercept is when x equals 0. So 3 times 0 squared minus 12 times 0 plus 15. That's going to get eliminated. That's going to get eliminated. Y is going to be 0, 15. All right. So we're going way up the graph here. It fits on the graph provided. That's a good sign. Look how sharp an angle this parabola is going to be. So we've got 0, we've got 2. We have to plot a few other points. Let's use our axis of symmetry as a clue. Let's go to 4. Y equals, and remember, you can plot any points you want on here, but you want it to be as advantageous for you as possible. 4 squared is 16. 16 times 3 is 48. 12 times 4 is 48. Well, that's nice. Plus 15. So our y here, when x equals 4, this is 15 as well for another point. Okay. So we can't guess, but I think we need to plot definitely one more between 0 and 4. 1's going to be the easiest thing, I think. And then that axis of symmetry is going to help us. It's going to basically do 2 at once for us. 3 times 1 squared minus 12 times 1 plus 15. 1 squared is 1. 1 times 3 is 3 minus 12 plus 15. 3 minus 12, negative 9. Negative 9 plus 15 is 6. Did I do that right? Why does that sound funny? No, that's right. Confidence, 1, 6 here. All right, what would 3 be? If 1 was 6, what will 3 be? 3 squared is 9. 9 times 3 is 27. 27 minus 36 is negative 9. Negative 9 plus 15 is... Oh, there we go. 6 here. All right, and we do our best to graph it if we can, like so. Woo! Do our best on the graph. We always try to make it pretty around here. Yeah, so that's how you graph a parabola. It takes a little bit of work, but it's all the skills that you know how to do so far in the year.